What is going on, guys? Christy here, and in this episode, I want to show you how I would approach creating an API client that is at the same time simple, extensible, and elegant. This will make it very robust, and I can guarantee it will make your life easier. Now, beginners might struggle a bit with keeping up with this tutorial, so I think it would be most appropriate for intermediate programmers. But I'm pretty sure that beginners can at least take some tips out of it and at least see some hopefully clean code written out of it. So without further ado, let's jump right into the code. Alright, so today we're gonna try and use the iTunes Search API to illustrate the API client that we're going to build. So just go to Google and type in iTunes Search API. And here it is, the actual API description. It's not very long and it's not very detailed, but it should get a point across. So what we're going to work with is the Search API, which in its simplest form is this. And one of the reasons why I picked the iTunes Search API for this example is that it simplifies things a lot because it doesn't need a separate app that you have to create and authenticate with. So that's very important because at this point, I just want to create the simplest, most customizable and expansible API client in Swift. So for that reason, we obviously want to start simple. What you can do with the Search API, if you scroll down a bit, you'll see there's various parameters that you can pass in. And we're going to focus on the music part for this example. So we're going to create an app that allows you to search for the music by a specific artist. And for that, we're going to pass in the term, the media type. And if you scroll down a bit, you can see that you could use the attribute parameter to specify what exactly to search in. In our case, if you look at the music category, we're going to search by the artist term. So we're basically going to implement a search where you enter the artist name and the results will basically be all the music that artist has created. It's of course is going to be paginated, but we don't worry about that for now. I'm going to switch to my body Postman right here. If you haven't used it before, Postman is a very advanced API client. It gives you the opportunity to customize your requests so that you can see exactly what's coming in from that API. If you look at the top here, I have the URL for the actual Search API, and I'm using the term, media, and attribute parameters to filter the results. And of course, we won't need all these fields, but it's useful to know they're here. We are going to just pick the fields that we're most interested in. I'll get to that in a second. At some point, I would also want to get some information on the artist, for example, and there is a separate request for that. It's using the lookup API. So if you look here in the iTunes Search API documentation, you can see that there are some other examples. The one I'm using is this one, lookup by iTunes artist ID. The artist ID is part of the response for release for that artist. All right, so that takes care of the setup for the API client. Now, I've created a starter project, which I intend to use for future lessons as well. It's pretty basic for now. It's just one view controller. And this view controller is supposed to display a grid with the cover images for the releases that we're going to pull from the iTunes API. I wouldn't worry about this code for now. I'm going to show you how I got to this point in a different lesson. You'll see that I have some placeholders where the actual calls are supposed to be done. So the basic structure is using a storyboard. I have a basic navigation controller that has a view controller with collection view in it. And then the collection view has this type of collection view cell that I defined here. It's a basic collection view cell that has an image view. And I have some code here that downloads an image if you provide an URL. Going to the view controller definition, it's basically configuring the UI. It also binds to the model. We have some callbacks here when an error occurs and when the results get in. We configure a search controller, easiest way to have a nice search bar at the top. That search bar will have the delegate at the bottom. It will try to get those results from the API. You also have some configuration for the collection view, and that is pretty much it. Now moving on to the view model, you can see that I left here some placeholders for some functions that I didn't implement. We're going to do that in a second. So I wanted to create this API client as simple as possible, but at the same time as extensible as possible. I'm trying to accomplish this without using any external libraries and instead focusing on the existing stuff that's already available in UIKit. This means I'm going to rely on URLSession instead of using something like Alamofire, for example. I'm also going to use codable structs and callbacks as closures instead of using something like promises. I chose this route so that everyone can use it straight away without worrying about learning any new libraries. So the first things we're going to do is going to keep our things organized. So I'm going to create a new group called remote, create a new file called API, and we're not actually going to define this class. It's just going to be a namespace so that we can keep everything modularized properly. So I'm going to have this, for example. Then let's keep things organized again and use a different file in which we'll define the actual types. So again, I'm not going to use this. I'm going to use the extensions. And inside here, I'm going to define the structures that are going to map one-to-one with the JSONs that we're going to get from the API. I forgot to mention this, by the way, but that API returns JSON objects. And Swift has a very nice way of encoding and decoding structs, for example, directly mapping them to JSON data. The way it works is you create a struct and you make it adhere to the Codable protocol and just use a JSON encoder or decoder to map it. I'm going to show you how in a minute. For now, let's go a bit deeper into this module and define a types enum. Now, you might be wondering what I'm using enums for. Enums are a great little way to structure your code. And this enum will hold our responses. To figure out how the response would work, we'll actually have to look at the JSON. But first, let's prepare ourselves. We'll create a new structure called artist search. And if you go back to the JSON, you'll see that this JSON has a results count and a list of results. And then each result can be defined as a separate JSON. And it has a bunch of fields. Most of them we don't need at this point. We'll just pick the ones that are more interesting to us. So let's copy this. Now this var, we can define it as an individual structure. Let's do something like this. And then we'll create a substructure. For this example, we're going to focus on the artist ID, which is an int, the track name, which is a string, and let's also get the artwork. So the artwork, as you can see, has some variance. It goes up to 100 by 100, but we're gonna go around that in a bit. Let's pick this field. It's also a string, and this should do it for the artist search. Now, in order for Swift to be able to convert that JSON into this struct, we're actually going to have to make it be decodable. So decodable is a protocol that lets you use a struct with a JSON decoder, and as you pass along data to it, if it resembles this structure that you define, it will map it one-to-one. You see that we actually left out a bunch of the fields and we're only interested in these three ones. It will discard the rest of them. Let's also have an empty struct here for reference. As we grow our API client, we might need to add some request objects as well, especially useful for post objects. You can see that I'm using encodable instead of decodable. This is because I'm expecting these structs to be encoded into JSONs, not decoded from JSONs into structs, which is typically what we're going to do with request objects. We'll create a new file. Let's call it API client. Let us use the same convention as before. So these namespaces are very useful because then when you need to call them, you can just do something like, and you have the namespace for the API, for example. You can do the same thing with the types we defined earlier, for example, like this. And this is how you get to the artist search response type. So before we actually dive right into writing the client code, we also need some other types here. Some errors so that we keep the good practice of writing custom errors. We also need some way to define the URLs or the URIs of the API calls, and maybe the method type, if it's a get or a post or a put or delete and so on. So let's go ahead and start with the errors. We'll make it a localized error. And then this is an actual enum because we want to create separate cases that make sense for the rest of the code. For now, I would always start with a generic. This is something that we can use off the bat. And then I would also use an internal one, which I'll just use for debugging purposes. Now, internal is a keyword, so I'll have to escape it like this. And then, because this is a localized error and I want to display this error to the end user, we're going to need some friendly names. So let's just use the error description for this. And we'll go through these options and decide what we're going to actually display the user. Then let's just implement the endpoint definition, and we are going to use the same enum style like the error to define our endpoints. Now, in our case, for the first example, the endpoint is search, and we have some parameters here. So we want to pick those up. So let's say search, and we will need the actual term. We also have a different endpoint that we're going to use, which is the lookup endpoint. And we will need an ID, which is an integer this time. Now, this is all well and nice, but it doesn't mean anything to the API. We're going to have to define a method to extract these parameters into a varied URL. So let's define a variable that is of type URL. We iterate through the case. And we also have the lookup. Now, for each of these, we're going to build the actual URL. And for building that URL, we're going to use URL components so that we don't have to worry about escaping anything. Let's add the host. We will get it from here. The scheme, HTTPS. And then let's return it at the end. We know that it's a valid URL, so we can just force unwrap it here. Now, for these endpoints, we need to define some parameters like the path. So in our case, path. If you go back here for search, it's actually search. We are going to add the beginning slash because it's the root. And for the lookup, the components path is lookup. If you go here, you can see that it's named lookup. And now these have some separate parameters. For example, here we have the term, the media, and the attribute. The media and the attribute won't actually change, but the query will change. So as you can see, we only need the query parameter to the endpoint. So let's add them in. Query items. And each of these is a URL query item, which has the name of the parameter and the value. So in our case, we have 3 of them. The first one is called term. The second one is media, and the third one is the attribute. The term will actually be whatever we passed along, so it's query. The media is music, and the attribute that we're searching through is the artist term. So that's it for the search, and for this one, we only need the ID, which is the actual ID, but we need to pass along a string. So let's interpolate it like this. Let's make sure everything builds. And let's also use a method enum just so that we can keep track of the HTTP methods that we're going to use. Get and post. Let's make this be a string. Now we're ready to go ahead and implement the API client. Let's keep it simple and create a reusable shared instance to access the API client. Let's also write the signature for the most common call that we would make. Let's call this method fetch, and this is going to need some parameters like the endpoint, the endpoint we defined earlier. We also want the HTTP method, we also defined it earlier. In case this is a post type of request, we'll also need the body. And at this point, we need to introduce the concepts of request and response. And because we want to make this as scalable as possible, we're going to generalize this method by adding two separate types. One of these will be request and response. And we'll have the body be a request type. Let's format this. That could be nil by default. And we also need a way to get back to the caller asynchronously once the request has completed. And for this, we will be using the result type. The result type in Swift is a very nifty way of packaging a response or an error in case something went wrong, so that you can keep your return types neatly organized. So in our case, it will be a result, and it's also a generic type, so you need to pass in response. And for the error, you also need to specify the error, and we're going to use the error that we defined earlier, which is types.error. And this returns void, and it's also optional, and it's also defaults to nil. We're doing this so that we can do quick fetches, even if we don't need a response, something like a ping to the API or something like that. Let's also make the method be get by default. And these types, request and response, obviously don't map to anything right now, but we just need them to be encodable and decodable respectively. So let's add this right now. Is encodable, response is decodable. So this method would basically build up the URL request and handle the network logic. This is the endpoint URL. Remember that our endpoint has the ability to generate the full URL. So we just pass that along here. We then set the HTTP method. The raw value is what the HTTP method parameter needs, which is a string. If there's a body attached, let's also add that in. For this, we actually need the data, so we have to encode the request body. We're going to use JSON decoder and JSON encoders to do this. So let's just have one defined at the top so that we don't issue a new one every time we need to encode or decode. Let's make this a constant. So we're going to use that. And we have our request type here, which is the body. In case anything went wrong, let's just log the error. And remember, we defined an internal error. I usually use that to identify if it's a coding error or not. So let's use the callback. Remember, it's optional. And this is a failure with the type of internal. And the reason is could not encode body. Again, this should never happen, but just in case. And let's just also return. Now let's create the data task to handle this. We'll use the URLSession. For this purpose, we'll use the shared one. You can always configure a custom one. We'll use the URL request we created earlier and the completion handler, which returns some data, response, error. If there's an error, let's quickly return. This time it's a generic error. Let's also print the error object as well. The error object often has more information to it than just the localized description. If not, if let data, let's try to decode it. Remember, decoding uses exceptions, so you always want to guard against it. Decoder, the response from data. This time as a success, and it's the result. If not, then another error came up. Could not decode data. And let's also log this one here as well, because there might be, especially when you're coding the structs that are going to be mapped to the JSONs, you might get some fields wrong, and the actual error will help you identify which fields you got wrong. And let's also resume this. Another useful thing you could do is return the actual data task so that the caller to this API can also cancel it if it's not needed anymore. But to keep things simple, we'll just leave it out for now. Since most of our requests will probably be GET requests, let's create a shorthand for that as well. That will basically just call this method with some parameters filled in. And for GET, we don't need the actual request type. We only need the response. We still need the endpoint. We don't need the method anymore. The only other thing that we need is the callback, which is pretty much the same, which can just copy it. And we'll just issue a fetch with the endpoint. Method is get, body is nil, and then the result, we'll just pass it along. And if you try to build this, you'll notice that the body cannot be a literal because it's expecting it to be an encodable. So let's just use our fake request for that. There's also a compilation error here. We'll need to actually use self, but the error we're concerned of is this one. It says that the generic parameter request could not be inferred. So let's do that now. Let body is of types request empty, and it's optional and it's nil, which is what we need here. And we also need to make sure that the response is decodable, like we did here. And this should silence things up. Great. So now we have the API client up and running. Let's go ahead and use it. So going back to our home view model, we see that we have this type, which is called release, and it's a music release. And it has some fields that we'll need to basically convert when we get the API response. And these are being used inside the view controller to fill in those cells. So in order to do that, let's first implement the API call. We can just use api.client.shared, use a get, and the endpoint is search. We already have the query and this parameter. And let's just use the callback. So this normally would be the call to get the search results. But if you try to build it, you will see that it can't infer the response parameter. That can easily be done by just making this parameter explicit. And we're going to do that right now. We're going to make it be a result of types API types response artist search, which is what we need. And the error type is API types error. And now it should be good. If you try to build it one more time, you can see that it builds. It looks a bit ugly and it's pretty verbose, and there are ways to circumvent that. But for now, it will have to do. We finally got the result. Let's make sure that we stay on the main thread, because that's an API call. It might get asynchronously on a background thread. So let's make sure that we go on the main thread, because we're going to just update the view with this information. And then we switch on the result. So if there's a failure, let's just log it right away. We already have on error callback that's being used by the view controller. So let's use that one. And since we're on a async block, we need to use self as well on error. And we'll just have the failure localized description that we can just directly display to the user. And if this was a success, you'll see that the success is actually the artist search struct. But that doesn't have what we need, which is an array of releases, which is defined here in the view model. So in order to accomplish that, we're going to have some sort of method that will just fetch and parse this into what we need. So let's call it something like parse results, and we'll pass along the success object. And of course, we don't have that method yet. Let's implement it now. Let's keep the things organized. And our results will be this result type. And this will basically extract the results from here, convert them into an array of releases, set it to the results variable, and then call the onResultsReceived callback so that the view controller will update the UI. So remember that the artist search has a result count and the number of results and the array of results. And each result is defined by this struct, which has the artist ID, the track name, and the URL. So going back to the view model, let's just create an array of local results, which is what we need, an array of release structs. We're going to return that. And then let's iterate and results dot results, which is the array of artist search results. Let local result is release, and we have this bunch of fields that we need to fill in. The ID is simple, result dot artist ID. The image URL will get on in a bit because we want to convert that. The title is pretty simple as well. Result, it's the track name and the artist ID. Result artist ID, and this is actually let's also add the track ID, which is also an int. And now we have this being the track ID, and this is the artist ID. And for the URL, let's create a separate convenience method that will actually get the 100 by 100 URL, and we'll just replace the 100 by 100 part and create it to the resolution that we actually need, which is going to be larger than that. And you can see that we already have a cover size defined that will tell us how big the cover art will have to be. Convert cover URL from a string, and let's just directly convert it into a URL. Return from replacing occurrences of, and we have this 100 by 100. Let's just use that cover size. Cover size. Cover size, that height. But since these are floats, let's just avoid having any floating numbers here. Just convert them to ints. And all of this has to be a URL. From a string, and we'll just force unwrap it here. And here we'll just use convert cover URL from result artwork URL 100, and then add it to the local results, local result, and that should be pretty much it. Oh, and we actually don't return anything here. We're just going to self results equal local results, and since we're here, let's just also call our onResults received callback, which is an optional. Try to build one more time. Everything a-okay. Let's try to run it, and let's try and search for resilient. And sure enough, you can see that some information already came in, which are the results for the query we passed in. So there you have it. The API client is now working. And in order to illustrate how easy things will be going forward, we're going to try to create a new endpoint and show you how easy that is. So back into our API types, we have a response for artist search, but we also want to look up the actual artist by using the artist ID. And the iTunes API is basically using the same API. And depending on the ID, it will return to you whatever you need. In our case, we're just interested in the artist. So let's use the lookup API, for which we already created the endpoint here. It passes along the ID, but we also need to define a response for it as well. So let's go ahead and do that now. It's also decodable. It also has the result count and the results, like you see here. Every response has that. Let's define the result. And this result struct is different than this one. You can see that it's inside a different parent. And this result also has some different values in it. What we're interested in are the artist name, which is a string. Let's say the link, which is also a string. And let's say the primary genre, which is also a string. So now we have the response for this endpoint. Let's go back to the home view model. And there's another method here, which is handle release selection. And it's basically being called whenever you tap on a cell. So going back to it, let's try and fetch that information. So you have API client shared. It's still a get. This time it's a lookup. And the ID is the actual result. Release is results index path row. And the release has the artist ID. And then we have a result. And for this one, let's also make sure we're on the main queue. And for this one, let's switch the result. It's pretty much the same as here since it's a result type, but the actual success is different. And we need to make sure the same way that the result is of type artist lookup, same type of error. And then you'll see that the success is basically the artist lookup struct that we're looking for. And in our case, we're just going to print it. Artist details came in. Let's just print it, and in case there's an error, we'll also print that error as well. Failure, localized description. And yeah, let's try to run it one more time, see what we get. Looking for this guy again, and then if I tap on a cell, there's some information being logged here, and it's actually what we were looking for. You can see that the artist lookup result came in with the artist and the link URL and the genre. Yeah, so you can see how easy it is once you set it up to create new endpoints and basically grow your API client. I hope you enjoyed this tutorial and found it useful, and if you did, please don't forget to like and subscribe to my channel for future content just like this one.